Hi there, welcome to watch this video. Let's start. Here is Shannon. Let's introduce the Shannon Tweezers ST42 today. Here is the menu, and it's about the navigation control, hotkey, and many other introductions. The most important one is here, discharging the capacitor before measurement. And our logo is like a smile ghost. Look at here. Okay, this side is the menu details. They include quick seat system measurement shutdown, and there are many measurement details. Look. This one is a USB Type-C charge wire, and which could download the firmware for the tweezers, and let's introduce it later. And here there are two different type keys for the Shannon tweezers. This one is the plastic one, and let's have a look. Well, Shannon tweezer is inside, and here is that. Okay, let's have a look about the dimension, and it's about 184 millimeter, and this side is about 62 millimeter, and this side is about 25 millimeter. Okay, this is the first one, and I mean it's stable enough and to keep Shannon tweezer safety. Okay, here is the other one. This one is beautiful than the plastic one, and the touch feeling is much better. And let's have a look about that. Okay, here has a calibration board. And this one is Shannon tweezer. Okay, and this one is the leather for Shannon tweezer. Let's have a look. Which is very convenient. Shannon tweezer is just like a pen inside. If you want to put Shannon tweezer in your pocket, I think this is the good choice for you, and to protect the tips and to protect the tips to hit somebody. Yeah. Okay, so here is the case and accessories. So let's have a more detail about the dimension. This one dimension is about 213 millimeter, and this side is about 43 millimeter. And let's have a look about that. Here is 32 or 33 millimeter. Okay, let's have a look about the Shannon tweezer. So the dimension is very suitable for usage. And this side is about 150 millimeter. Okay, so we can use this one. This side is about 19.4 millimeter, and this side is about 14.25 millimeter. Okay, here is the more details about the Shannon tweezer, ABS cases, and look at the keys. It's very beautiful, and look at the details. And here is our logo, and Shannon Tweezers is the model number and the SN number. And here has 2 screws, and here has 4 screws for the Shannon Tweezer. And this side is a Type-C connector. Well, here is the stainless tips with golden planted. It's easy to tear them down and to replace. Let's have a look at that. Here has 4 screws. If you want to it's easy to replace, and current measurement for while. So it's easy to replace the tips if you want to change the other type. Well, very good. Slice. And then look at the details. Here, that's some. So, it's hard to move. Okay, started. Yep, the default setting is automatic measurement. So here is the hotkey, press the menu, quick seater, press again, and here, that's auto now. Well, let's have a look about the measurement accuracy. And here is the calibration board. And for the resistors, they are 0.1% accuracy and 25 ppm per Celsius resistors. And the capacitor, I think they are maybe 5%. And the inductor, I have no idea, maybe it's about 10%. And resist and diode and LED. Okay, let's start it. Okay, here is the default automatic measurement. So before the measurement, let's do the calibration first. So press the key, selector measurement, and selector calibration. Okay, and self calibration. TIA 10 kHz, PGA TIA 1 kHz. Okay. Open calibration. last one. Short calibration, so keep the tips to be short. Before it keeps short, it's better to make the tips clean. Okay, let's do it. Okay, so let's start it to measure the calibration board. The first one is short, so the offset is about 10 milliohm. I think it's because of the contactor resistance. Okay, first one is 10 ohm, 100 ohm, 1 kilo ohm. Wow, it's very accurate. 10 kilo ohm, 9.999 kilo ohm, 100 kilo ohm, and 1 megahertz, mega ohm. Yep. And here is the capacitors. First one is 10 picofarad. The second one is 100. The third one is 1 nanofarad. And here one is 1 microfarad. It's 100. Okay, this one is 1 millifarad. And measure the inductor. Let's select the L firstly and do the test. It's 10 micro ohm. So test result is 9.7. And select the diode. Okay. Look at here. It's the diode offset. Here, 0.51 volt. Okay, last one is LED. Let's have a look about that. Wow, no problem. Yep. Okay. Quick set automatic auto low, and we can have a test about the hold function. Quick set, select measurement, calibration, hold, select on. Okay, let's have a look. Measure 1 kilo ohm. Let's hold. Measure 1 nanofarad. Wow. 1 millifarad. Very smart. 1 mega ohm. Okay. Other quick set such as second parameter, model, and existed. Here, the hotkey is use this navigation control. So the up one is to change the measurement frequency. Up is 120 Hz, 1 kilohertz, 10 kilohertz. Okay, this one is automatically selected the frequency. Let's have a look. If we select this one when measure the large capacitor, it will select the low frequency automatically. Okay, and the below, the down is to select the excitation voltage. Here has 4 selection, 0.1, 0.451 volts, and 1.2 volts. Okay, the left and the right is to select the model. Here is capacitor, resistor, inductance, capacitor, and impedance, ESR, diode, LED, RDC. Okay, automatically. So if you want to use the automatically measurement, just press hotkey, select quick set, and select the faster selection auto law. Okay, now we start. Okay, that's measurement. Here is the 10 kilo ohm, 10 ohm, sorry. Here is 1 micro ohm. Okay, thank you. The secret of the precision measurement is we use the pure sine wave as the excitation, voltage, or signal to do the test. Look at the screen. Shannon Tweezers screen is 1.0 volt and 10 kilohertz. And look at the oscilloscope. It's very clear, 10 kilohertz and 1 volt peak-to-peak sine wave voltage, and we can change the frequency. So use the navigation control. So up. Okay, here is 100 hertz. Okay, let's have a look about that. Yep, it's 100 hertz and 1.0 volt peak-to-peak voltage, and this one is 120 hertz, and the measurement is 120 hertz, and this one is 1 kilohertz, and we can have a look about the frequency is 1 kilohertz, and the voltage, peak-to-peak voltage is very stable, and the duty cycle is 50%, and here one is the 10 kilohertz. Well, there are many other interesting test results. Look at the screen. It's about 10 kilohertz and 1.0 volt for the measurement, but the test result is the R, P, and C. Look at the test model. It's a resistor parallelized with the other capacitors, and the RP is about 10 mega ohm, and the capacitor is about 22 picofarad. But if we switch the probe to 1.1 ratio, let's have a look about that. Okay. Well, look at the test result. It's about 1 mega ohm parallelized with 170 picofarad. So when we do the high frequency test, we have to choose the 10:1 ratio probe for the test, because the capacitance is much smaller than the 1:1 ratio mode. Well, and look at the test model. It's a resistor parallel with a capacitor, but when we do the test, the main parameter is the capacitor, and the second parameter is the resistor. So the frequency is 10 kilohertz, and if we switch to other frequency, look at here, it's 100 hertz, and the test result is different. Is about 1 nanofarad. Well, here is 1 kilohertz, and here is 10 kilohertz, and here is the 10 kilohertz and 100. So look at the screen. It's 100 hertz, and the capacitor is 1.1 nanofarad, and the RS, look at that. The parameter, the test model is changed automatically, and now is the resistor serialized with the capacitor. So when we choose the 120 Hz, the tester model is the same to 100, but the capacitor is smaller. This one is 1 kHz, so it's switched to resistor parallelized with the other capacitor model. So the test result is 10 MHz and 22 picofarad. Now it's 10 Hz, and the test result is similar. It is same to the test before. Well, here is the automatically test result. Okay, let's switch to different test model. So this one is the automatic mode, and the test frequency is 10 kHz, and the excitation voltage is 1.0 volt peak to peak. And let's switch to another mode. So this one is a resistor, so it's the similar one, and this one is the inductance, and we still use the pure sine wave to do the test. And this one is capacitance, is the test result 22 or 23 picofarad. And this one is impedance test result. Next one is ESR, so we can have a look about the test waveform is keep the pure sine wave. Well, here is the diode. Let's have a look about that. What's that? Well, the diode test mode, and look at the waveform. It's about the pulse, because when we did the diode measurement, we use the DC volt or DC excitation to do the test. And the next one is LED. So here is the pure DC to do the test. And the next one is RDC. Next one is automatically mode. So this tweezers selector the capacitor mode, and the test frequency is 10 kHz. So the result is very stable.